digital world, data travels from one device to another in a way that might seem like magic. But there's a method to this madness. It's all thanks to something called the OSI model. Even though you don't see it, this model is working non-stop behind every message you send, every game you play, and every meme you forward. Each OSI layer takes care of one part of that journey. So the next time your text goes through instantly or your FaceTime doesn't lag, remember, it's not luck. It's the OSI model quietly doing all the hard work behind the screen. At the very top, we have the application layer. This is where all the magic happens that users interact with. From sending an email to browsing the web, it's the layer you experience directly. Once the data is ready to go, it moves down to the next layer. Next, we have the presentation layer. Its main job is to make sure that the data sent from one device can be properly understood by the receiving device. Basically, it's translated, encrypted, compressed, or reformatted so that the receiving device can understand. This layer also in charge of data encryption and decryption. Now it's the session layer's turn to step in. This layer manages the conversation between devices, setting up the connection, keeping both sides in sync throughout the data exchange, and properly closing the session when it's done. If the connection gets interrupted, the session layer knows exactly where things left off and can resume the session without starting over. Next up, the transport layer, the reliable delivery service of the OSI model. It takes your data, chops it into smaller pieces called packets, and makes sure each one gets delivered to the right place, in the right order. It also controls how fast or slow the data should travel to prevent network congestion. The transport layer does this using two well-known protocols: TCP, Transmission Control Protocol, which offers reliable connection-based delivery, and UDP, User Datagram Protocol, which is faster but less strict. Now, we're at the network layer. This is where routing happens, the GPS of the OSI model. Each data packet is given a destination address, like a digital zip code, so it can find the best route across the network. It handles tasks like packet forwarding, logical addressing, such as IP addresses, and even error handling when routing issues occur. Next up is the data link layer. This layer takes each data packet, wraps it neatly, and adds a local address using a MAC address, which tells it the next hop on the way to its final destination. All of this is packed into a box called a frame. The data link layer prevents data collisions, and even fixes small errors that happen during transmission. And finally, at the very bottom, we have the physical layer, the foundation of it all. This is where data turns into actual electrical signals, light pulses, or radio waves that travel through real, physical media like cables, fiber optics, or wireless signals. Without it, all the clever addressing and framing from the upper layers wouldn't matter. There'd be no way for anything to move at all. It's not glamorous, but without this layer, nothing else works.